All right, so looking at the warm-up, it says find the value of x. So this is the geometric mean one. Let me clarify real quick the geometric mean. Again, we're using this because the triangles are similar. Now, if you look very carefully, what type of triangles are they?
Right.
They're all right triangles. If there's a 90-degree angle here, there's a 90-degree angle here, which means these are both small right triangles. And then overall, this is a big right triangle. So it's only when you have the altitude drawn inside that it's a right angle, and then therefore we can use the geometric mean. And I say that because today as you're working on the homework, some students wanted to use the geometric mean on the homework. Well, you can't use it unless it's the altitude on a right triangle. Okay. All right, so from our theorems from the last section, is this an altitude theorem or a leg theorem? Altitude. And the altitude is always equal to the square root of what times what here? What's 9 times 3? 27. So x is going to be 5.196. Good. All right. When you're ready, we can put up the warm-up. Our last section is parallel lines and similar parts of triangles. Going off of what we did Friday, if two lines are parallel. Friday we said if these were parallel, then these portions here are proportional. We can make a proportion. Friday we said we can put this portion over this one and this one over this one. Now we're doing the converse. So the converse says only if these are proportional can we say these are parallel. So if you notice in this example, there's no arrows. The question is this line parallel to this one? The way to determine that is we're going to take our pieces, so 90 over 72, and we're going to set it equal to 50 over 40. Now, you can reduce it or you can divide it. I don't care which one it is. All right, what do y'all want to do? Reduce it or divide it? It's up to y'all. What do y'all want to do? Divide the fractions or reduce the fractions? Reduce them. All right, let's reduce them. What's 90 over 72 reduced? What do we get? That's using the ABC button. So 90, ABC, 72. 5 over 4. What about 50 over 40? 5 over 4, were they equal? All right, we'll say yes. And this is your explanation on your homework. So if it says why yes or why no, you're just showing me yes, the numbers were equal, or no, the proportion was not equal. Okay? All right, that's picking up from Friday. All right, then we get into the midsegment of a triangle. So midsegment of a triangle states that a midsegment, which is connected by two midpoints, this one, oh, wrong pen, this one and this one, is parallel to the opposite, to the side that is going in the same direction. So these two sides are parallel. If they're parallel, then this midsegment is half the length of this one. Well, if I look at half the length, how is the half length marked? With how many tick marks? 3. So I'm going to put 3 here. 1, 2, 3. All right. Same thing with this midsegment. If this is a midsegment, then it's parallel to this one. So if half of it is A to P and R to Q is half, how should I mark this one? With 1. If I do the same thing with the last one, this one over here, this side is parallel to this one. How should I mark that midsegment? With 2. So with 2. 1, 2. Okay. So do y'all agree there are 4 little triangles inside the big one? Can we say those triangles are congruent? Yes. By what reason? Side. Not similar. We're saying they are exactly the same. So keep in mind that once we say triangles are similar, so if I say triangle RCQ is congruent to triangle PQB, then we can say R is congruent to which angle? P. R is congruent to P. We can say C is congruent to Q. And then the last one should be Q is congruent to B. And that should be for all the triangles. This one should also be true. 1 should be here, 2 should be here, 3 should be here. Because if you picture this being one triangle and sliding it, if I slide it on top of this one, it matches up. If I slide it on top of this one, it matches up. What would I have to do to the triangle to match up with this one? We'd have to flip it or turn it in some way. But all 4 of them are congruent. All right, because you'll need that piece on the homework, just to remember that they're congruent. All right, and just like I said, these 2 line segments, your mid-segment, the segment in the middle, is parallel to the side. And if that's true, then J to K is half the length of F to G. So that means if this is 10, what should J to K be? 5. All right, so as you add that to your notes, go ahead and erase this part right here, that F to G. I think it might be correct on yours. All right, at the very bottom, we have a triangle that looks like this one. All right, we're gonna go ahead and add all the pieces. So you guys stay on your page. I'm gonna go to mine. All right, so this one here. So given that G, J, and K are midpoints, G is in the middle, so these 2 are equal. J is in the middle, so these 2 are equal. K is in the middle, so these are equal. So I'll give you guys a moment to get that copied. I knew that just because they're midpoints. Now, according to today's topic, one of the topics, it says if this is a mid-segment and it's parallel to the side, this is how much of this whole line? Half. So how is half of it marked? With how many tick marks? 3. Just like we did earlier. 1, 2, 3. All right. So then if I say this side is parallel to this side, to this mid-segment, how should I mark G to K? With 2. And then the last one, this one here, how should I mark J to K? With how many? With 1. Okay. So look at the first question. Label the congruent segments, and we did. G to J is parallel to what side? G to J is parallel to what side? D to F. If it's a mid-segment, they should be parallel. What do we know about segment G to J? How much smaller is G to J than D to F? Half. So you're going to write that. Remember, we did this when we did centroid. Remember we talked about how we can set up the equation? G to J is half the length of D to F. All right, what is congruent to G to J? What segments? D to K. What else? K to F. All right, I'll pause there. Okay, so what about D to E? D to E is parallel to what line? K to J. So then what can we say about D to E? How much bigger is D to E than K to J? Double. It's twice as big, right? So we can say D to E is twice as big as J to K. And what's more congruent to E to G? D to G, and what else? J to K. Good. All right. So that's it with mid-segments. Let's use mid-segments here. It says X to Y is a mid-segment. If this is in the middle, if this is a midpoint and this is a midpoint, this line or this line segment is congruent to what other segments? Z to T, and what else? S to Z. So what would these links be? To each one would be 7 because they're all equal. All right, X to Z is the mid-segment, and this is equal to what other 2 segments? R to Y and Y to Z. Now the whole thing is 13. What would half of it be? 6.5. And I'm just going to add that here, 6.5. I know that bottom one doesn't look equal. I would agree with you. All right, what is the length of X to Z? What did we just say it was? 6.5. What's the length of S all the way to T? 14. And then what? Okay, so this one. What is the measurement of the angle of X, R, Y to X? R, y to x, this one right here. So keep in mind that these two are parallel. This line is parallel to this line, so technically we have these arrows here. What do you think that missing angle would be? 124, good. What kind of angles are they? Alternating interior, good. All right, and that's it for mid-segment. For the rest of the notes, most of it's going to be proportion. And do you remember how many different ways we can write a proportion? There are 4 different ways. Technically, there's 2. But if you talk about like really changing it, like making sure the numbers are in the same spot, it would be 4. Do you remember what the most important thing is when you write a proportion? The order. It's the consistency. You have to be consistent. The way you write one is the way you have to write the other. Okay, so if you have 3 lines that are parallel, 3 lines that are parallel, then these little pieces here, they're going to be proportional, just like it was the other day when we looked. Do you remember we looked at this triangle and we said if these are parallel, then these pieces are equal, right? And I said put this one over this one, this one over this one. Same thing. This one over this one over that one. Or you can go top to bottom, doesn't matter. So they want us to find x in this one. What is one way I can set up this proportion? It's just the way we set it up. So how do I want to set up the first fraction? What do y'all think? All right, so if he decides to do 26 over x, what has to be a second fraction? 13 over 16, good. What if he decided to do x over 16? What would have to be the second one? 26 over 13. So again, it just has to be set up the one way. Now, you can go top to bottom, left to right. Never say x is to 13. That one won't work. That's the one that won't work. So you can go top to bottom, left to right. You just can't go diagonally, okay? All right, next thing. So this one looks identical to it. Does anybody just see the difference just based on the image? What's the difference here? The lines. What do these lines mean? That they're equal, right? That they're congruent. Anytime anything's congruent, it's equal. And anytime anything's equal, what do we do with them? If it's equal, set it equal. Good. So if these two are marked equal, we're just going to set them equal. You're going to say 3y plus 8 should equal 5y minus 7. Don't solve it. We are just setting it up. I know y'all know how to solve. So the theorem states that if they're equal, then you can say, not you can assume, you can say that these have to be equal. So then you would set these equal to each other and then solve from there. And that's it. So only if they're marked equal can you go ahead and set them equal and then say that the opposite parts are also equal. All right, look at this one. This one is a mid-segment, the one we just looked at. And I know it's a mid-segment because the sides of this point are equal and the ones of these point are equal. And there's also this arrow. All right, so tell me, how would we solve for y? Set them equal. They're equal to each other. 4y plus 6 equals 2y plus 18. All right, that's for the y's. What would I do for the x's? How much bigger is this one? Double. So you can say x plus 11 is twice as big as 4x minus 5. Or we can say, how much smaller is this one? Half. We could also say 4x minus 5 is half the length of x plus 11. Either one of these would work for x. It doesn't matter which one, it's the one you want to use. All right, when you're ready, we'll go to the last page. You guys are going to give me different setups, okay? So for the last page, these are special segments we've already seen. We've talked about altitudes. We've talked about angle bisectors in the past. We've also talked about medians. Now what these do is these are cutting the triangles into proportional parts. Now, this is looking at how many triangles? 2. They're all looking at 2, okay? So as you look at 2 triangles, you're looking at these 2. All right, Ricardo, give me a way I can set up this proportion. What do you want to put x over? X over? What do you want to put x over? There's 2 different ways, so just pick one. 8. All right, if he decides to do x over 8, what has to be a second fraction? 15 over 12. All right, or we can do x over 15. What would have to be my second fraction? 8 over 12. Either one would work. Some kids like to go from one triangle to the other just because that's what we've been doing, and that's fine. All right, Enrique, how do you want to set up the next one, Enrique?
12 over 8.
All right, so if he decides to do 12 over 8, what has to be his second fraction? 5 over x. Has to be x over 5. Remember, the arrows have to go the same way. Remember the consistency, right? One more way we can set this up. What would be one more way?
X over 12.
X over 12. So if I decide to do x over 12 instead, what would have to be your other setup?
5 over 8.
5 over 8. Good. How many triangles were we looking at? 2. Good. The reason I'm pointing that out is because if you look at the last one, this is within one triangle, not 2 triangles. You have an angle bisector, and this angle bisector is dividing these 2 pieces proportionally to those 2 pieces. So let's do B first because B is more straightforward. It's one triangle. I'm going to do 15 over x. What would have to be the second part of my proportion? Good. What if I decide to do 15 is to 9? If I'm going side to side, x is to 6. Good. And again, just different ways to set it up. All right, then comes the last one. Not that this is hard, but it's just different because you're having to figure out what you're going to put there. Now, when you do this setup, we used alongside a side and then the part that was split. So here's the side. The part that was split is missing a piece. Suppose x is 7. Let's pretend x is 7. What would y'all do to figure out the other piece? Subtract it. So do the same thing. If x was 7, you would do 18 minus 7. So let's do 18 minus x. And that's your missing piece. Okay. So how do I want to set this one up?
6 over 14.
All right. So if he decides to do 6 over 14, what has to be his second fraction? X over 18 minus x. Good. Jason, can you give me one more, Jason? Jason, what if I did x over 6, Jason? What would have to be the last one? What do you think?
18 minus x over 14.
There you go.